Now we look at this beautiful picture. You have these two galaxies here, and they are M81, 82, Messier 81, 82. I'm sure you all know what's a Messier object, all right? And interesting is this comet. So basically, this comet is what? Very near in solar system, but these are galaxies very far away. These points are stars closer, but they're all in Milky Way. And these are outside Milky Way, all right? These are other galaxies. Now we look at this. Why does it have an anti-tail? So it can be explained. Now, wait a minute. Wait, comet, pen stars. There you are. Now, imagine we look at the entity. It's a situation like that. This is the sun here on the left, and below here, below left is the Earth. So when you look at it, remember, this comet is coming from the top, going around the sun in a clockwise direction, right? And of course, Earth, looking down from Polaris, is orbiting around the sun at an anti-clockwise direction. So that means this comet is a retrograde comet, going around the sun at a clockwise direction, retrograde comet. Earth around the sun is prograde orbital motion. So now you have the coma of the comet. The coma is, of course, the solar wind go and heat up the what they call the nucleus of the comet, which is actually ice and dust. And the ice and dust will the ice and dust will evaporate and expand, is formed the coma. And then the what they call the solar wind, which is what they call ionized particle, electron, proton, will hit this particle from the sun and go and form the iron type 2 tail, the straight tail, the iron tail. And these iron tails are basically the ionized particle, electron, proton, and the ionized elements. But then you have the dust, normal dust. A dust, of course, bigger, and the dust will have a broad spectrum of velocity, and will have a curved tail because the dust are bigger and smaller. And you see, you look from the Earth here, from the left to here, to about 3 o'clock. You go further, you see sticking out there's another tail. So this is the anti-tail. So this anti-tail is actually much further away than the coma and the ion tail. So if you look again at so this is the coma close to you. This is the dust tail closer to you, but this anti-tail is much further, all right? Much further, all right? So this is called the anti-tail. So basically, you come back to this telescope Pan-STARRS. Each time I look at Pan-STARRS, takut. We already heard of Pan-STARRS what? In the year 2000, the American plan. It's already built in a place called Maui Island in Hawaii, all right? And then on this place is called Haleakala Observatory, all right? This is not in Mauna Kea, next to the Keck telescope. Keck telescope is on Mauna Kea Island. This one is on Haleakala. Now this is on Maui Island. So they built inside on this mountain top 2 similar telescopes, 1.8 meter diameter primary mirror, Ritchie-Chrétien. And what is interesting is not the telescope 1.2 meter normal. Is this one? Takut. The biggest CCD camera in the world, 1.4 billion pixel wide angle, So with this level 1.4 gigapixel, do you know what is this telescope or not? When it was proposed in the year 2000, many of the amateur astronomers, the amateur comet hunters, don't like it. They're scared. Why? I call this this Pan-STARRS observatory. I call it the giant vacuum cleaner. So what is this? In a few nights, you scan the northern and southern sky from Hawaii. So a lot of the part of the units can be scanned. Good weather there. Not much cloud. It's above the clouds. In a few nights, it can sapu. Sapu means take pictures of the whole universe. And every few nights, maybe I don't know how many petabyte. And then maybe we have the algorithm, the software to go look for comet, look for asteroid, look for nebula, look for supernova. Crazy, So with this kind of telescope, I would say they have pushed the amateur astronomers out of a job. So do you know what many of the amateurs will do? They will go into Pan-STARRS observatory database, and there's not enough. The professional astronomers don't have any time to scan the data to discover new comet, new supernova, new asteroid. Amateurs can do it It's called data mining. So now you cannot build this telescope in a few nights. If the sky is good, you take pictures of the whole the universe from there, and then maybe next week take again the whole series. You may say, you already taken the whole series The whole universe last week we are doing it because there are many what transient events. The universe keep on changing, dynamic things are changing every day, every night. So what you took last week and this week, maybe there's a supernova exploded, and this week the supernova is expanding some more, and next week expand some more. So that means in a few nights they gas up, they sapu the whole universe. The next week sapu the whole universe again. Fantastic lah. This is our telescope lah. So each time I think of this observatory, takut, you know. You go and vacuum. This I call it the giant vacuum, gigantic vacuum cleaner. All right. Now you see, talking about the entity, many years ago, our what do you call this Lulin Observatory in the center of Taiwan. This is the Lulin Observatory. They also took a famous Comet Lulin. We also saw it in USM. All right, in Penang lah. I think was it in this on what they call Bukit Genting Observatory. And this is the coma. This is the ion tail, and this is the anti-tail. So Lulin, Comet Lulin also got. And this is the dust tail, curved tail. All right, this Comet Lulin, and this is the anti-tail, and this is how you see it. How you see beyond. This is the coma. This is the Earth on the left. This left is the sun. Coma, the iron tail, straight tail here, right? And this curved tail. And from here you see the early. This is the anti-tail. So this is the anti-tail. So anti-tail is far behind. All right. So what about all these points of light? The points of light are the stars in the Milky Way galaxy far away from us. All right. So now we go back. And now we talk about this Oort Cloud. So comet Pan-STARRS, this comet is basically, I repeat, this is not a real exactly. This means that right in the center is our sun, and very close to it are the 8 planets, Mercury to Neptune. And say, remember, all right, I repeat, from the center here, the sun, to the next star, our Proxima Centauri is about 4 light years. So that means from here to the edge of the Oort Cloud is 2 light years. Remember? So if you ask me what is the exact size of the solar system? The exact answer is the exact size of the solar system is from the sun to Proxima Centauri about 4 years. So in between is 2 light years. So whatever is inside this sphere of 2 light years is the sun, solar system. So solar system is defined as, the best definition is wherever the gravity of the sun still is dominant. That is the solar system. So I repeat, here is the sun, and very close to it is Neptune, and here is here in a sphere, spherical cloud of comets, and not a single comet in the Oort Cloud have been observed because they are very dim, But the scientists have done so much research; they are 100% confident that the comets in the Oort Cloud exist. So the Oort Cloud exists. All right. So now another big number. What is the research number of comets in the Oort Cloud? They run into the trillions, typing trillions and trillions of comets in the Oort Cloud. So the Pan-STARRS comet far away, maybe here, say 1 light year away. Many years ago, there's on the right, there's another star passed by outside the Oort Cloud, and the gravity of the star will affect this Pan-STARRS comet 1 light year from the Earth. But if that star on the right doesn't pass by the sun, the Oort Cloud, then that nucleus of the comet will orbit the sun very far away, never to enter the inner solar system. But because there was a star passed by earlier, the Oort Cloud, so gravity affected a bit. So now, that nucleus now is on a kamikaze mission. Instead of going around the inside the Oort Cloud, never to enter the sun, now go closer into the inner solar system. Inner solar system, what? Towards Neptune, towards what we call Uranus, and closer to the sun. So that Pan-STARRS comet is from the Oort Cloud, first time visitor, right? So what happened is, if you go around the sun, it may go around, slingshot effect, it may go out of the sun, and maybe back into the position, and it may come back. How long it come back? It all depends. So if that comet either coming into the close to the sun, never pass by the planet Jupiter, and on the way out from the sun, never pass by Jupiter, because Jupiter has a big influence on the comet. It can perturb, it can affect the orbit of the comet. So if the orbit of the comet is changed, then on the subsequent orbit, you go not so far from the sun, it may come back to the sun. And the second time you come back to the sun, Jupiter is there, then the Jupiter may trap the comet into the solar system. So we don't know where is the location of Jupiter. All right. So that's our comet Pan-STARRS. We continue. This is interesting. All right. This is our Dragon. Dragon means Crew Dragon 2 lah. The spacecraft, but launched by SpaceX Elon Musk to go and to join with the ISS and send the 2 American astronauts to the ISS. All right. So basically, in Central Park here, this guy Stan Honda. Now, Stan Honda is a kind of a photojournalist. That means he's not an astronomer, not even an amateur astronomer. He takes photojournalists, all kinds of pictures on the ground or maybe political event. He's a Japanese American. He took it in Central Park in New York and saw in the sky here. Wow, this is what is it called? Comet train. I repeat, this does not mean that you take a picture of one satellite in the space and you close the shutter. No, the same satellite, and the same satellite, open the shutter, see the same satellite, close the shutter, no satellite, open the shutter, same satellite. No, this is Starlink number 1. Starlink number 2, here there are 1, 2, 3, 4, there are 5 Starlink here. Here we see how many? 1, 2, 3, I can see 30. So that means there are 30 Starlink satellites in the line orbiting above 400 kilometers above New York City. And remember, I've been to New York before. Can you imagine a big city of New York, right in the center of the city? It's called Central Park. It's a beautiful park, all right, a beautiful park. And that park, I understand, is about 4 kilometers in area. So it's about it's a square of 2 kilometers by 2 kilometers. And here, what jogging law? It's not Bukit Jumbang, much bigger than Bukit Jumbang, much bigger than Botanical Garden. So green, what they call Central Park with a lake, and you see the Comet train. And remember, last night the Falcon 9 by SpaceX, they launched another set of Starlink. Crazy. Remember, each time they send the Starlink satellite that look like that. I'm dead against this Starlink. So this is a Starlink satellite that was launched by the Crew Dragon. This is of course artist impression, and it's not like that. Each time when they send like that. This is actual picture. This is the Earth. There are 60 Starlink stacked one by one, and they drop off here, drop Starlink 1, 2, 3, 60. Each mission they'll launch 60. So as of today, it seems there are 500 Starlink already orbiting the Earth. So they even have a grid. So what about the GPS constellation of GPS satellite by the Pentagon? It's about 60 only. But eventually, now there's 500 Starlink in the space about the Earth. Eventually, the FCC approved Elon Musk to launch 42,000 Starlink. Half days. What does it mean for us? Do you not see the implication? In fact, before they launched Starlink, we already realized that they shouldn't do this. I mean, every night in the sky, sure got hundreds of Starlink. Already many of the astronomers, in fact, the astronomers are dead against it. So the FCC is a American Federal Communications what they call corporation, government body. They approved Elon Musk to set up. So basically, what is Starlink? Starlink is they will have thousands, tens of thousands of these Starlink satellites that will beam towards the Earth, internet everywhere in the world. If you are in the middle of Sahara Desert, no problem. The internet information is from the space. You are in the jungle, you are anywhere, no problem. But it doesn't mean that the internet information is beamed directly to your laptop in the jungle. No, you still need a terminal on the ground. So this satellite will beam the internet information by radio to a simple terminal, like something like an astro dish on the ground, and it's a terminal. And that terminal on the ground will send the information to all the other devices on the ground. Then you can access internet. So eventually, this Elon Musk intend to beam down to the what 5G 5G all the world covered by 5G. That means what? Sorry lah, our DG close shop lah. Sorry Nexus close shop lah. All the internet service provider close shop because you have one free one from space, 5G, and dangerous. So first of all, we don't know whether 5G, the radiation, high radiation frequency may be safe or not. The other one is, sorry, already people complaining about many of the satellite sent into space, not Starlink, and now you have this Starlink in sent. That means you have this problem. Look here. So in future, every night you cannot have a nice astro photograph. All right, that's the problem. All right, and you must remember, the Starlink satellites are very low. No, you cannot say, I will find out when is the next Starlink, when the next Starlink train will come. 60 of them will come. So I will prepare that it won't come. The problem is, each Starlink won't last long because it's in low Earth orbit, 400 kilometers. So they will decay in low Earth orbit. They will burn in Earth's atmosphere. So after 1 or 2 years, they send a new set of Starlink to replace the old Starlink. So the orbits of the satellite keep on changing. You never know, right? But anyway, this is the Starlink. Sorry, so I repeat. This is the So this is Crew Dragon, right? So now we go to the last few. This one I like. All right. Portrait of NGC 3628. Stefano Cancelli and Paul Morfield. These are two, I think, amateur astrophotographer from Canada, right? So this is NGC 3628, very nice, all right? And of course, this one, they mentioned that this is interesting. There is one galaxy here, and some of this is taken by amateur astronomers, all right, with the telescope with tracking. But I think Hubble was taken before. There's someone call it the hamburger galaxy. It's a galaxy. So what is it? This is your daging daging lembu. This is your lettuce This is your tomato sauce This is your sandwich. But it's actually a galaxy. So this is what our astronomers do. But then, far to the right, there's another galaxy which you don't see. And the galaxy on the right, outside the picture, is interacting with this hamburger galaxy. And that larger galaxy is pulling out the stars from this galaxy. So this galaxy is shedding, it's losing stars out here. So these are all stars, no, this is not smoke, secret smoke, billions and billions of stars being pulled out. So this is a tidal tail. And of course, these are all stars in our Milky Way. And why this star got 4 spikes, that means the secondary needle holder is 4 vanes, 4 of the wires holding the second needle. That's why it got 4 spikes. If the spider has 3 vanes holding it, then it will be 3 spikes. 2 vanes, 2 spikes, but this is 4 spikes. That means the vane holding the second needle is 4, right? So this is a interacting galaxy. There's something called it the hamburger galaxy. Very nice, right? So again, if you look at this picture, sorry, why so beautiful, Same thing lah. The play of gravity, the play of the speed of light. And thank you, Professor Planck. Your Planck's constant is very small. Now we go back to the earlier one, which I said before I was cut off. You will ask yourself, what happened? What happened if the value of the Planck's constant is not so small, but actually 0? Now, I repeat, because of the Planck's constant is so small, that means that many of the quantum phenomena happens at atomic scale, atom scale, molecular scale, in the atomic world. You cannot, some people say quantum phenomena cannot be seen in the macroscopic scale, in the scale of the equipment in your laboratory. Now, no, there are certain phenomena in superconductivity. You can see the macroscopic manifestation of quantum mechanics. But basically, quantum mechanics is seen only on atomic scale. So, for example, because of the Planck constant, do you know that, you think carefully, because of the Planck constant exists, so the electron energy level around any atom or molecule is quantized. N is equal to 1 at atomic number 1, 2, and 3, and got sub-atomic number also. And because they are quantized, the difference between the two levels is due to the Planck's constant. It's not Planck's constant is not 0, so there's a change in the energy level. And because of the change in the energy level, Planck's constant, your transistor can work. Imagine if your Planck constant is 0, the transistor in your handphone, in your laptop cannot work. It can work because the Planck's constant is that tiny value. And because the Planck's constant that value, your CMOS chip in your handphone that record the picture, your CCD chip in the camera that take the picture can work. If Planck's constant is 0, your transistor cannot work. Your laser pointer cannot work. Your practically everything can work. And you think even bigger. The chemical reactions in your body, you eat the nasi just now, you digest it. Why? Because the electrochemical reaction to digest the nasi lemak, the chicken that you ate, the drumstick you ate. And basically, what is electrochemical reaction? It's quantum mechanics. Because of the energy levels in the atoms, in the molecules are all quantized, then you have all these chemical reactions. So chemical reaction occur in your body, you digest the food because what the Planck's constant. So if the Planck's constant is zero, the whole universe is different. Maybe it cannot exist. And you would think even deeper, if the Planck's constant is actually zero, no value, even the atoms in the body cannot be bound together. Let's say a piece of rock, why is the rock solid? Because of Planck's constant so small. But if the Planck's constant is zero, the rocks, the silicon, the proton, the electron cannot be bound together. Maybe you just torn apart. So basically, the Planck's constant is very small, happens to the atomic world, but because it's not zero, a lot of things in the universe can happen. So Planck's constant is a very deep meaning, because of that. All right. So we continue to the last few. This is what I like. Okay, this line. So now I repeat. You read here. This is done by our JAXA, our Masale James O'Donoghue, who works in the Japanese space exploration. This is the Japanese NASA, but the data is from NASA. All right. So you see, it says that basically is that every time when remember basically the sun is in the center, Mercury is not in, Venus here orbit around the sun in the anti-clockwise orbit, Earth also. So it's only sun, Venus, said that every time when the Venus go around the sun at a faster rate and the Earth go around slower, the Earth goes around the sun once in a year. But every time the Earth goes around the Venus 1.6 years, the Venus face, the part of the face looking at the Earth is always the same. I'll show you the simulation. But before that, you may say, but how does the scientist know that the surface of the Venus is always facing, because the Venus is full of clouds? Now remember, many years ago, they discovered radio astronomy law. There are actually big, powerful radio telescope on the Earth, say the Arecibo telescope and the FAST telescope, the 500 meter in Guizhou in China, just open. You can beam the radio wave from the Earth. Of course, there's a delay lah. There's a time delay between the radio, but you beam at the correct time, delay time. The Earth radio wave from the Earth go and pass through the clouds of Venus, scatter back pass through the cloud, hit the surface of Venus, and scatter back to the Earth. And from there, they can map out the surface topography of Venus with the radio telescope. Right. So now with that, they know that every 1.6 years, the Earth goes around the sun. Venus will always point its same face towards the towards the Earth. So I'll show you now the simulation. All right, there you are. I'll tell you when. Look at the Earth now. Okay, look at the Earth. 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 1 year has gone by for the Earth. Okay, one year. Another 0.6 years. 1.6 years. Okay, that's one year. So there's another year for the Earth. Another 0.6 year. 1.6 year. So every 1.6 year, the Earth goes around the sun. Venus will show the same place to the Earth at inferior conjunction. So this is what law of gravity. This is called resonance. So the orbit of Venus with the Earth has a 1.6 year resonance, facing the space of the Venus pointing towards Earth. So this is applying the Newton's law of gravity. Right? So we continue. The second one. Okay. Now, okay, coronavirus attacks humanity. This is from one of the American, infectious disease center. Of course, you may say, Dr. Chong, I already know lah. Why you bring in the COVID virus? I give you more information. So basically, this is not coronavirus. The coronavirus is all the round orange round dot. Of course, the crown with all the things sticking out, it's not seen lah. So there are millions and millions of those coronavirus particles sticking on this bigger cell somewhere in the human body. coronavirus. All right. So this is about coronavirus attacks humanity. So now maybe I can bring something relating with coronavirus to astronomy. You say, how come? It can be explained. Okay. So there is a I use the word possibly, a connection between coronavirus and this what you call astronomy. It's called the Panspermia Hypothesis. Now I was in USM at the time, Bachelor of Physics, 1974. Big news, you know. I saw in the New Scientist magazine, British magazine, that two scientists, all right, left Professor Fred Hall from Cambridge, Professor Chandra Vikramasangi from Cardiff University. They came up with the idea of what? This one, no? Panspermia hypothesis. So what is this? They already know that all the meteorites that fall onto the earth, they cut out the meteorite from the center so that the center of the meteorite is not polluted by the earth's material. They found in the center of the meteorite what? Many organic material. Amino acid, benzene, formaldehyde. And they use the telescope, the radio telescope especially, they look at the Milky Way, they found what? All types of molecular clouds are very, very complicated. You will say ethanol, which is alcohol, methanol, and many, many organic molecules are found in interstellar space. For example, you look at the Horsehead Nebula. Horsehead Nebula is basically a molecular nebula, all types of molecules. And also from the tail of the comet, the ion tail, the dust tail, they look at the spectrum of the comet. They found that in the tail of the comet got organic molecules. So these two, Professor Fred Hoyle, Sir Fred Hoyle from Cambridge, and Chandra, by the way, Chandra Vikramasangi is still alive, you know. He originated from those days they called Ceylon, now called Sri Lanka, all right, but now working in, maybe retired, University of Cardiff in Wales. So they come up that actually the earlier idea of how life began on the earth is called the abiogenesis hypothesis. That means the life on the earth came from non-living things, and then later on living things came. For example, the understanding for a long time is the life on the earth originated in the ocean, not in the land, not in the air, in the ocean. That means you have a lot of UV light from the sun, those days when the earth was very young, no ozone layer, and a lot of violent activity on the earth's surface. So it created from non-living chemical, water and hydrogen, maybe carbon, sulfur, they come to form organic molecule and more complicated organic molecule. And somewhere along the line, DNA was formed. DNA is the magic, the life molecule. So one DNA was formed, you can duplicate to many similar DNA. And the next step of DNA is what? Single cell, amoeba, paramecium. But of course, they have done a lot of experiments on the earth, you know, from organic material, they can make organic material, but they are not from the lab able to create a DNA lah, or even a worm, a cacing, not yet lah. So basically, these two guys say that even with the abiogenesis theory may not be true for the earth. So where did the life come from the earth? From space lah. That is, the comet dust, all right, fall into the Earth's atmosphere and created the meteors, the bright streaks in the sky. They bring back to the Earth's surface what? Organic material from the comet. And where did the material from the comet come? Maybe from some of the stars earlier that died and created life. And this life was in the comet, floating around between the stars and finally captured by our solar system. And the comet passed by the Earth and created a lot of meteors. And the dust fall into the Earth's surface and carried the organic material, maybe life, the DNA and so on. Right? So according to them, the life started from outer space. So this is called the Panspermia Hypothesis. So at the same time, it's not only life, you know, whatever things is possible on the Earth from space, including what? Virus. Remember 2003 SARS virus? I was in USM. I think it was about 2005 or 6. I saw in the New Scientist magazine that some of the, not astronomers, the scientists in UK, United Kingdom, did some research. Because that time they say that the SARS virus started somewhere in China, right? And then the poultry, right, was infected. And they brought the poultry to Hong Kong. And spread to Hong Kong, SARS. And then from Hong Kong, spread around the world. So this group of scientists in UK said, oh, They made some simulation. They said that, oh, the SARS virus started like that. According to them, according to the Panspermia Hypothesis, they said that earlier, before the SARS virus spread in China and Hong Kong, there was a kind of object, say comet or something, passed by the Earth, and this comet material went into the Earth's atmosphere over Tibet. And the wind blowing up in the atmosphere in Tibet later brought it and let it settle down in South China. And this virus brought on by the comet went into the civet cat, a type of animal in the jungle. And later on, the civet cat infected the poultry, all right, caught by the people in South China, and they go and sell in the market in Hong Kong. And the people in South China and Hong Kong kena the SARS virus and then spread around the world. So this is the Panspermia hypothesis. So in a sense, we can say that if you ask me, is it proven that the Panspermia hypothesis is wrong? Not yet. It's right? Not yet. We don't know. We never know. So in future, they may prove that, yes, some of the diseases like virus or whatever, dengue or whatever, actually originally came from space. Then it can be said that, in future, virus come to the Earth maybe from space. The Panspermia hypothesis is not disproved yet, right? So we go to June the 1st, right? Yeah, nice. So this is our center of our Lagoon Nebula in Sagittarius. I'm sure many of you have seen the Lagoon Nebula, right? So in the center, this is a place where you have star formation, right? You have emission nebula, absorption nebula, and maybe some here you have also a reflection nebula. So this is the center of the Lagoon Nebula, right? So this it says here from left to right is about 15 light years, right? And this is by what? Sorry, by NASA. Okay, but you see, now many of the amateur astronomers are so good. It's processed by one Argentinian guy, Diego Gravinese. So original picture, soft copy by NASA, and then processed by this amateur astronomer. But then you see, how come got NASA and ESA? Basically, you see, the Hubble Space Telescope is something like jointly owned by NASA and by ESA. Because ESA has got a lot of observatory on the ground. ESA also got a lot of observatory in space. So anything about Hubble Space Telescope to do with NASA and to do with ESA also. Okay? So it's processed by this amateur astronomer from Argentina. Right? So I think that's about all I covered today. Okay? So Michael, any question? Young-Lip, any question? Hello?
Anyone have any question?
Any question? Now, before we go to any question, next month is special. So, ladies and gentlemen, I actually wanted to give this presentation for so many years. Remember, we have been following APOD for so many years, and the unexpected pictures are so beautiful, so unexpected. So next month, it will be like this. Jewels of APOD. Of course, not ruby not tourmaline Of course, these are real jewels. What I mean is the beautiful astronomical object that they presented in APOD all the past 25 years, which I like. Right? In fact, you ask me, if I present a lot, it will take you many months. Maybe I have my own selection end of next month. All right, that is the jewels of APOD. End of next month. All right, my selection. Okay, now Michael, any question?
Any question from the participant, from the audience? Yeah, if no, I think we end the session for today. We thank you, Dr. Chong, for the great presentation.
Yeah, thank you, Michael. Okay, thank you.
Thank you, everyone, for coming today.
Yes. Okay, so you are going to put on YouTube.
Thanks.
I have to check with my house.
Yeah. Okay, so we can stop today.
Yeah, sure. Thank you.
Thank you. Good
Thank
night.
you, everyone.
Bye-bye.